Swayam Prabha. Digital India. Educated India.
So good day and welcome back to this class on which we will focus on generation and control of leachate. So in the last 3-4 lectures we have done a lot about liners and something about covers. So we've got the envelope now. We've got the whole waste in an envelope of impermeable barriers, which is the philosophy of dry tomb landfills, right? Now, how are we going to handle the two emissions which are formed inside, the leachate which is formed inside and the gases? So that's going to be the next 2-3 lectures. And today we look at leachate. So leachate is the liquid which is squeezed out from the waste. That's one part, as well as the water which infiltrates into the waste and percolates through it, carrying substances dissolved from the waste. So water becomes a solvent. Whatever is soluble will get into the water and will come down with the water. So the leachate is the mobile component which causes contaminants to travel away from the solid waste mass. So if there was no leachate, then at least in the liquid phase nothing would move out. It's still, there could be dust, there could be particles which could move out, there could be gaseous emissions. But as far as the liquid phase is concerned, whether it is polluting surface water or whether it is polluting groundwater, it is the mobile component. And let's go back to this diagram which we have been working with. We've talked about liner, we've talked about cover, and today we are going to talk about that if you have infiltration and if your barriers don't work, some water will come down, or if this is a perfect barrier, the waste itself may be wet, and as you build up the waste, it will squeeze the pore liquid out. So how do we handle this liquid which is coming at the base? And you would recall all the diagrams. We have a composite liner here, and top of the composite liner we have a 30 centimeter thick layer where the leachate is collected. So we are going to talk about leachate generation and control. First we'll talk about quality, then we'll talk about quantity, and how the liners and the drainage and the collection system help us to collect this leachate. We don't want it to go out in an uncontrolled manner. And then what do we do with the leachate that we have collected? That's going to be the sum and substance of what we are doing today. So it's very difficult to predict what will be the quality of leachate. So suppose I was to ask you, please predict what will be the quality of leachate. How would you go about it? I could give you a lot of waste, but I want to ask you what will be the quality of leachate. So there are two issues in the quality of leachate. One is the constituents, right? And second is their concentration. So we need to know what will come out and what will be the concentration. And how would you go about it if I was to ask you to estimate the quality of leachate in advance? You're going to make a landfill, you know this waste is coming, the waste is available from an old dump. How would you estimate the leachate? So if there is no old dump which is available, then quality would have to be necessarily simulated in the laboratory, right? And the simulation will be what? You will put the waste in a column, and you put some water on top, and you will collect the water at the bottom. So you may get the constituents in it, you may not, because this may be a 15-20 minute one-day test, whereas leachate may be generated over years. So you could do a column test by leaching water through the waste to get some idea of the constituents, and the concentrations will what about the concentration? Concentrations will depend on what is the height of the column. In the field, the height of the column may be 15-20 meters. So water is traveling through 15-20 meters of waste. Therefore, the concentrations may be high. In your lab, you can't make a 15-20 meter high column. So the concentrations may be different. Plus, inside the waste mass, a lot of reactions may be occurring if it's a biodegradable component is high, or if it is municipal solid waste. Therefore, now the factors which will influence the leachate quality will be the waste composition, the time, the temperature, the moisture, the oxygen, and other factors. So it's complex. Leachate quality varies significantly over a period of time, but broadly speaking, leachate quality will reach a peak value. That means the concentration of the contaminants will first reach a peak value, and then they will gradually decrease. As more and more water comes in, they will gradually decrease after the peak value is reached. In biodegradable waste, in municipal solid waste, availability of oxygen has a huge effect. Whether the reactions which are taking place inside the waste mass are in aerobic condition or anaerobic conditions. Because the contaminants or the chemicals released during aerobic decomposition are different from those released due to anaerobic decomposition. Landfill conditions are by and large anaerobic in the lower portion of the landfill, but when you are depositing fresh waste, there is oxygen in it. So they gradually change from aerobic to anaerobic. So these are the complexities that are involved, and if you look at the concentration of the leachate constituents, and if you look at time, from a landfill many constituents may come out. So they will reach a peak value. This could be chlorides, this could be something else, this could be heavy metals, and then they will tend to decrease. It's almost as if the waste is being gradually washed off of the contaminants which will be carried away with water. Not all contaminants will come with water, some will be the pore squeeze liquid. Also, there may be products of reactions which may not dissolve in water, but they are liquid themselves, right? So if you have organic waste and some reactions are taking place and the outputs are immiscible liquids, they'll come out by themselves, which will not ride as a solution in the water. And just to give you an idea of the complexity, I don't know whether this slide is very readable, but if I take municipal solid waste landfills, and if I go through literature and see the kind of contaminants that we can study, so there will be some biological contaminants, there will be some organic contaminants, there will be inorganic contaminants. So here is a list of parameters: pH, turbidity, conductivity, suspended solids, dissolved solids, chlorides, sulfates, hardness, alkalinity, nitrogen, sodium, potassium, calcium, magnesium, lead, copper, arsenic, mercury, cyanide. Inorganic, under organic, COD, TOC, acetone, benzene, toluene, chloroform, and other compounds. And biological, BOD, coliform bacteria, fecal coliform bacteria. So really, to be able to characterize a municipal solid waste landfill leachate, you have a large number of parameters. And what bothers us? I mean, if I have leachate coming out, what is bothering you? The concentration of the constituents should not be very high, right? If I take ordinary soil, and run a heavy metal analysis on it, there will be some heavy metals in it, but they will be very, very low. And if I take some groundwater, which we are using for drinking purposes, and if I run some groundwater quality analysis, we will get chlorides. But again, they will be lower than the acceptable limits. So what bothers us about the leachate? As long as everything coming out is within limits, no problem. But if it is more than the limits, then there is a problem. So, when I say we should test so many parameters, what do we compare them with? I mean, these are all the parameters of contaminants in the leachate. I need to compare them with some limits. So, what limits should I compare them with? So, I have leachate constituents. Should I compare them with drinking water standards? Why not? Eventually, if the liquid is going from the waste mass into the ground, into a groundwater which I am using for drinking water purposes, then should I compare it with drinking water standards? Well, one of the set of standards which are available in the codes is the drinking water standards. Are there other standards which are available? So, this is the acid test. If the leachate is meeting all the standards, great, you can drink the leachate. No, don't be scared about it. You be very confident of your testing. You be very confident of your testing. But don't be scared about the fact that I can't drink my leachate. Is there any other standard by which we can say, all right, our leachate should meet this standard? What other standard do we have in the IS code?
It can be disposed on land or pond.
So, I also have pollution control standards of, this is like the landfill is treated like a factory. So, the effluent coming out of a factory is subjected to the pollution control board norms, right? The pollution control board officials will come once every month randomly and take your sample. So, there are standards for discharge to drains. What can come out and go to a drain? So, you will have to check this out in greater detail, but there should be standards for discharge to drains, discharge to rivers, and discharge to ponds or lakes. If the drain is going to a effluent treatment facility, then it will have some pre-standards about what the effluent treatment plant will accept. If it is going to a river and if it is going to a pond, the standards will be different. Why? A river is flowing, so whatever mixes with the river, it gets diluted, more fresh water comes from behind. But in a pond or a lake, the water is not flowing. So, if the water is not flowing, the standards will be more stringent. And of course, drinking water standards will be the most stringent. Over and above that, we have more standards, I understand. Discharge on land. Discharge on land. So, do you think the most stringent standard, of course, is drinking water standard, right? And discharge on land, and I have not looked at the standards in great detail, but it presupposes that there is an attenuation capacity of the soil, right? It presupposes that. So, maybe it is different from the drinking water standard. But for me, from a long term perspective, if leachate is going to come out for the next 20 to 50 years, then the attenuation, what have we understood? Attenuation capacity will deplete with time, and if the water table is high, then and if you are using your groundwater for drinking water purposes, then you are back to this standard. If your groundwater is already polluted, it has some high constituents, not because of your landfill, then at least you cannot go above the background levels. You understand? कहीं पे खारा पानी होता है, खारा पानी salty water, and कहीं पे पीने वाला पानी होता है. So if you have खारा पानी, then your खारा पानी means there is some high amount of total dissolved solids, right? So then your benchmark becomes that what you are putting on the land which will go to the groundwater should not exceed the what is already existing, higher than the background level. Okay. So how do we assess leachate quality? I began this debate. You can do laboratory tests. You can do water percolation through the waste, but I told you the limitations. You cannot simulate long-term percolation of several years, and the height of the column is less, right? So what do you, so if you look at the second one, acidified water percolation through waste, what does it mean? We are just trying to accelerate time. We say that in the acidic environment, more leachate will have more heavy metals, more of the constituents will be released. So if I have to do something very fast in the laboratory, I have to model it in some way. For example, how do we test the durability of a construction material in the laboratory? There are two cycles which I perform at a very rapid rate, which simulate what happens outside very slowly. Would you have any idea? I give you a concrete sample, a new concrete sample. I say I've made this new material. Can you just check with me whether it will last for 15 years or will it become, it will sort of disintegrate in 15 years? So how can you do a test in the laboratory? Well, there's a freeze and thaw cycle, there's a wet and dry cycle, and there's a heat and cool cycle. So what are the heat and cool cycle is simulating? Summers to winters, summers to winters, summers to winters, right? And wet and dry cycle is simulating rain and no rain, rain and no rain, rain and no rain. So in the lab, I can do the wet and dry in 24 hours. Whereas in the field, one wet and one dry cycle may be taking a few days or a few months. I can accelerate the process in the lab, and I can estimate the number of cycles which may come in a lifetime of 15 years or 20 years, and I can do that test in 6 months. So this could be the durability test. So these are accelerated tests. So when we study durability of geomembranes, which you will do in geosynthetics, there will be accelerated tests. When I study leachability of constituents, I talked about the TCLP procedure, something called the toxicity characteristic leaching procedure. There we are working on a pH of 2. So everybody asks me, why do we do this test at 2, whereas in the natural environment you are not going to encounter highly acidic or acidic environment. That's just an accelerated, how much is the total heavy metals which can come out, leachable heavy metals which can come out from the waste. So here also you can do acidified water percolation test. But the secret is, and this is not written in most of the textbooks, that if you have an old waste dump nearby, what you are trying to simulate in the lab is already happening in the waste dump. So go to a waste dump and drill a hole. Suppose the waste is 5 meters high, drill a hole to 3 or 4 meters. See if you get some leachate inside the waste dump. That's the starting point. If you go into the soil beneath the waste dump and try to get, maybe already some attenuation has taken place. So get the worst stuff, and maybe that waste dump came up in 3-4 years. So what you are trying to do in the lab has already been done. So if you can get an old dump, take samples from the old waste dump. I mean, Mohit has just come from a couple of waste dumps, and he says all around the waste dump he finds black leachate. I said, go, very nice, go collect it. Let's at least see what is there. What are we dealing with? Is it just that it is black color, or is there some contaminant in it? And he keeps on doing testing for heavy metals and heavy metals. And I said, no, test for salts. Test for dissolved salts. And suddenly he will give me, sir, heavy metal is 4 ppm and the limit is 3.5 ppm. Is it dangerous? I said, what about the total dissolved salts? Oh, sir, the limit is 1000 and we are measuring 20,000. So get the right constituent. Please look for the right constituent. I may have given you a list of 30, 40. So sampling from old waste dumps, you can drill and sample, or if there's a natural path by which it comes out, then it's accumulating at some place. Now I'm not saying that it is the worst leachate. It might have rained yesterday, therefore the leachate might have been diluted. but that is going to remain there. So go at the end of summers before it dries out and pick up that leachate to see what are the kind of constituents that you're going to get. So this gives you, why is this important? Because we need to treat this leachate in the end. If I don't have a handle on what are the constituents, what treatment plant am I going to make, right? So I'm going to treat this in the end. Other way is that you make a landfill, you don't have the waste dump, you are not confident of your lab results. Make the landfill, store the leachate for 1 year. Leachate will come out. This is on as is coming out basis. Store it for 2 years. If you operate a landfill well, you're not going to get that much of leachate which you can't store. If you operate it badly, then of course you have a problem because you can't store it. But if you cover it with temporary cover during the monsoons and ensure that very little rain goes in it, you can have leachate. And that you can test after 1 year, and then you can design any facility for that purpose. Let's look at the next aspect, and that is generation. And I tell you, this topic is important because again, you will find that a lot of discussion on the model. Rainfalls. Let's just go back to our cover and we'll understand what are the I really want to bring that diagram. So I'll come to the diagram, but if you recall our cover, I have not put the separators. And I'm just putting a municipal solid waste cover. So this is the topsoil in which your vegetation will grow, right? This is the protector layer, drainage layer, barrier, gas collection layer, and a foundation layer if you need one. And then the wastes. You all remember this? So we are now trying to estimate the quantity of leachate which is generated. And if you look at this diagram, it says precipitation, runoff, evapotranspiration, change in moisture, and then leachate. Okay? This is bulk, large, gross processes. Rain will fall. If this is sloping, rain will run off. Some of it will come in. What will happen here at the barrier? We have put a drainage layer with a very specific purpose that this will also run off. We have clay barrier. Something may go through, what we may call leakage, or we are designing it that something should go through. This will percolate through the waste, and this waste may be several tens of meters thick, and then it will come to the bottom. So to simulate all this, how much is falling, what is the infiltration coefficient, what is the runoff coefficient, depending on whether it is grass or not, a lot of mathematical models have been developed. A lot of mathematical models have been developed, and one is listed here. It's called HELP. It is a US EPA. It's available free on the net. You can use this for the purpose of computing how the leachate is generated. But the larger picture is lost because everybody starts to work with this model. And let's first understand what is the larger picture. Where is the leachate coming from in a landfill? Bulk of the leachate. The bulk of the leachate comes from the active phase. This is what you have to fundamentally understand. If I am taking out 100 units of leachate every day, bulk of the leachate in that 100 units is from the active phase. Why? Because in the active phase this doesn't exist. Why? Active phase, there is no cover. You are adding waste every day, right? And you are adding waste every day and it rains. So there is no cover. In the monsoon you can say I'll keep it covered because I'm expecting rain. But where 2000 tons of waste is being disposed every day. For example, in one of the landfills of Delhi, 2000 tons of waste comes. How many trucks are coming? 2000 tons of waste. 400, 500 trucks are coming in 24 hours. How many trucks in an hour? Twenty, 30 trucks, a truck every minute or two. What are you going to cover? These trucks are just coming and you have to spread the waste, and there are 5 dozers and the trucks are coming and the waste has to be spread, and it rains. So you say, no, rain is coming. Professor Datta gave a lecture, no, you shouldn't allow the leachate to form. Trucks will start lining up. You can't stop it. You can't stop putting your waste, and you can't have a temporary cover on the site all the time. In the monsoons you can be actively geared for this, right? But so what I'm trying to say is, it's the active part of the landfill which creates the leachate, and that is what you have to understand. That is the message which is normally lost in this water balance which we talk about. And let me see if we can quickly capture that. So in leachate generation, the main thing is, during the operation of the landfill, almost all the precipitation that falls on the active area infiltrates into the waste. So I'm going to compare 2 areas of a landfill. Again, it depends on how you are operating your phase, but if that is my landfill, this is covered, this is intermediate cover, and this is your active. If rain falls on this, will it run off in any direction if it is undulating at the top? If you don't finish it off and put a daily soil cover, will any rainwater run off? I can tell you, if rain falls on this, 100% of the precipitation will go inside. Some of it may be stored in the waste. But if waste coming itself is moist, then there is going to be no storage inside the waste. So this part of the landfill is going to create the maximum leachate. And that is what your design is for. The design is not with cover, whereas everybody starts to use the help model. The design is not for the cover, because here 90% of your water, if you have any well-designed cover with proper slopes and an internal drainage layer, 90% or more of the water is going to go, of the rainfall. Here 100% of the rainfall is going to come in, though it's a much smaller area. This is the area for which you do the design. How much leachate can you handle, at what rate is it coming in, and what kind of quantities can you handle. The rest of it produces very little leachate. So almost all the precipitation that falls on the operating area. So after looking at this, do you want to improve it? You would like to put a daily cover. A daily cover, because if the rain comes on the daily cover and if it is sloping, okay, 60% of it will go in. 70% of it will go in because it's only a soil, there is no vegetation on it. But still 30% of it will run off. So how you operate? And the smaller you make this area, the less, because what is falling outside is not coming into the leachate. So all the precipitation falls, some may evaporate, some water is held in the voids, balance becomes leachate, some pore squeezed liquids are also added. So this is the main thing. After the closure, final cover is placed on the waste. Most of the precipitation becomes surface runoff or evapotranspiration. Small portion of precipitation infiltrates. And what that infiltrates, again the internal drainage layer takes it away, and quantity of leachate is very small. And I come back to this diagram, what I have put on the board. These are the closed phases. This is the precipitation, and that's the runoff. So this will go to a surface water drain here. Okay? That's the active phase, and what falls on it will give you the main leachate, right? You have to have a berm here. You don't want the water which is falling here to come here and start coming down. So you have to prevent any water from any side coming into the waste. So this is the leachate, which is the active phase, and this is maybe giving you large quantity, and this may be giving you much smaller quantity of leachate. And how you operate this, whether you put a temporary cover, whether you make it smooth, whether you have a separate monsoon cell, all that determines the weight. Now, how does it make a difference? Every amount of quantity of leachate, every unit volume of leachate which comes out has to be treated, and there's a treatment cost. So you have to offset the measures which you take for reducing leachate versus the treatment cost. So let me again put this: during operation, leachate volume is equal to volume of precipitation plus volume of pore squeeze liquid minus volume lost through evaporation minus volume of water absorbed by the waste. So please understand, there is no surface runoff presumed in this equation. After closure, volume of precipitation, minus volume of surface runoff, minus volume lost through evapotranspiration in the cover, minus volume drained through the lateral drainage layer above the barrier, minus volume of water absorbed by the waste and the intermediate soil covers, plus some residual volume of pore squeeze liquid. Mostly pore squeezing would have finished as the phase builds up, but there may be some pore squeeze liquid or some products of reaction taking place in a municipal solid waste landfill. So leachate generation, total quantity and peak rate. Now when you are going to design a leachate collection system at the bottom, what are you bothered about? What is the total quantity of water you have to take out, or total quantity of leachate, and at what rate do you have to take it out? Let's take the example of a football field, right? We want the football field to drain out very rapidly. Two designs are done. Both designs can handle the same quantity of water which falls on the football field in a year, right? But it's not the quantity of water which falls on the football field in a year that is important. It is handling the peak rainfall which occurs for that 15-20 minutes when the game was interrupted. It's like the cricket field. You want to come back and play. To be able to handle that peak rain, what do you want? You want that your pipes and your pumps and the surface water drains should be able to handle that peak rate of water which is coming into the collection system. So peak is different from total. So the cricket field, which has a larger lateral drainage layer at the bottom with higher permeability, thicker, has larger surface water drains at the sides and huge pumps, and which actually tilts the field a little more, because the more the inclination, the faster the runoff. That cricket field will drain off faster. Of course, we don't want to make it so inclined that the ball runs to the boundary every time on its own, and the batsman says, no, this field is tilted like this. I don't want to hit on that side because there is an up gradient. I'll hit on this side because there's a down gradient. But sometimes, if you are listening to the commentators of the cricket match very carefully, why the bowlers change the ends. There is always a gradual inclination in the ground. They will talk about it sometimes, that when you deliver the ball from this end, it's better, or from that end, it's better. And when they are talking of uphill and downhill, they are talking of 1% slope or 0.5% slope. They are not talking about climbing a hill, right? So total quantity, volume per month or volume per year, is a fraction of the total precipitation. Please understand, about 75% from the active phase, more than 75, and less than 10% from the closed phases. That's the total quantity that you're going to handle in that year. So your effluent treatment plant or whatever system that you're going to set up must be able to treat that much leachate every month or every year. But the peak rate is going to be governed by your rainfall. And under what condition is your peak rate going to be the highest? Tell me. You have two situations. Peak rainfall occurs here, or let me make three situations. Peak rainfall occurs here, and peak rainfall occurs here. Which is the most critical rate? When the waste thickness is small or when the waste thickness is large? Well, the waste itself has some absorbing capacity. Even if it doesn't have some absorbing capacity, it has some permeability. So what falls on the top takes some time to come down. If it takes some time to come down, the peak will be gradually spread over a period of time when the waste thickness is large. But when the waste thickness is small, then the time lapse between what is falling and coming to the pipe is very little. So actually this is the worst case. Of course, the leachate will be diluted. The leachate will be diluted, however, you still have to handle it. So the peak rate, peak rate is a function of the peak precipitation rate and height of waste. If peak precipitation occurs when the waste thickness is very small, then peak leachate rate is almost equal to peak precipitation rate. Whereas if peak precipitation occurs when the waste thickness is almost full height, the effect is delayed. That is why, we are going to get peak rates in the monsoons. Remember that. So our phase, which month does our phase start in? Our phase starts post-monsoon. So let's say if Delhi has July, August, September. So my landfilling will start in October. God forbid if the peak rainfall occurs in October, but from October to June, I would have built up my waste, right? And I would like to cap the waste before the monsoons come with a full cap. That is the correct way of operating the phase. It's not that I operate a phase on January to December and during the operation of the phase for 3 months in between, I'm getting, I operated from financial year. A lot of things are governed by financial year. So if yours is an academic year, so you can always say I'll do it academic year, but financial year means you start the landfill in April and immediately 2 months afterwards or 3 months afterwards you start having a monsoon. Doesn't work well. Close your phases before the monsoons so that you have least amount of leachate. This I have already discussed, whatever we have talked, but a lot of people work on HELP. You can also work on HELP, and you can also, for your cover, simulate. You can simulate different thicknesses of the waste, how much leachate will come out in an active phase. Always the active phase is the determinant. Don't start with the covers because that is bringing out very little leachate. And let me give you an example here. This is an example which is modified from one of the papers. So in a place the annual rainfall is 600 millimeters per year and this much waste is coming annually. Infiltration active phase is 600. This is wrongly written, please. Annual precipitation is 600 millimeter per year and therefore the infiltration in the active phase is taken as 600 full. Capped phase only 200 millimeter per year. How much percentage is of this? Capped phase only 20 millimeters per year. Sorry, not 200, 20. So how much percentage? 3.33%. So only 3.33% is coming out. So let's say first year, active area 17,000 square meters. If full rainfall is taking place, this is the amount of leachate which is produced. And some of it is absorbed by the waste. only 9,900 is reaching out. In the second year, active area is 28,000, capped area is 12,000. Okay? From the 28,000, 16,800 is coming, 100% precipitation. And from this capped area, only 240, that means 1200 into 20. If I looked at the 20th year, 27,000 is my active area and 133,000 is capped. But from the active area, I am getting this much leachate. From the capped area, I am getting this. What I am trying to tell you is that as long as there is one active area operational, the amount of leachate coming out is very, very large. Though the capped area is very large. The moment the active phase finishes, the landfill produces much smaller quantity of leachate. Because now this is the full landfill area and you have to multiply it with this, because that's the infiltration rate, assuming that your cover is working satisfactorily. So during the phase when waste is being actively filled, you are having this. Suppose notionally I could reduce, see what we are saying is each active area is about 27, 28, 27, 28, right? This is just starting to take off in the beginning. Suppose I could have reduced this area. I have to accommodate the same volume of waste. How do I reduce the area which is exposed? Yeah, I mean volume is area into height. So if I had this, each phase was 10 meters high, suppose I had made a phase 20 meters high, then the footprint of the waste would be smaller. If the footprint of the waste is smaller, then the amount of rain falling on that footprint is smaller, and therefore the amount of leachate coming out is smaller. Now it may not be possible to do this, just I am saying, but keep your active area small, keep everything else capped, and please ensure water is not falling inside from outside. Just take an example of a below ground landfill if you don't operate it properly. And I am going to come back to that question which I gave you in the first minor. It is a below ground and an above ground landfill, if you recall, right? And there were 16 phases, you remember? 1, 2, 3, 4, 5, 6 kept going behind and behind and behind, right? So I had said, okay, we should operate it like this. If I look at it in plan, so it would be 1, 2, 3, 4. I could go 5, 6, 7, 8 or 5, 6, 7, 8, either way. Like that. You remember this? So can you give me the picture after 2 years of operation? Third year is active. First and second have closed. So we said you should go up. So after 2 years of operation, after 1 year of operation is over, you have closed it. I'm now operating the second phase. Is this fine? First year has been capped, I'm into the second year. Second year filling is going on. All that falls here will go. I want to ask you to make the next line. Does the line go forward? Have you excavated the full landfill? Is this how you're working? Yes or no? Is there any other way you'd like to do it? It's becoming a little tilted. Let me sort of. See, what I am trying to say is, if you excavate the whole thing, when it rains, this will run off. This water will also pond at the bottom, and you will have to take it out with a pump if you want a separate surface, even if you make a berm here. So how should you operate this? Maybe I should have operated it like this. Nobody asked me to make this investment. I mean, excavating is putting money, and you are the owner. Why would you make such an investment? You will do it next year. Or even this is not correct, because you should have said closed, in operation, and then under preparation. This is under preparation. The liner is being put so that next year when you finish, you can come and do this here. But in any case, don't do extra excavations, please. Whatever falls here, you can grade it away so that if the rainfall comes, this doesn't come in and this also doesn't come in. The problem is that if we operate like this, and if this water also starts to come here, then you have a lot of leachate, not only from the precipitation falling from the top, but also from this. And if this is sloping inside, and I have seen this happen, below ground landfills actually becoming ponds, because not enough precaution was taken to keep the water out. Any questions? Keep excavations to a minimum. So let me make closed, in operation, under preparation. So this rain will go down into the leaches collection system, and what rain falls here, it should go this side, and it should be taken out as surface runoff and put into the stormwater drain. The moment it becomes leachate, you are prevented by law to put it into the stormwater drain. And this berm is very important. It separates the leachate, keeps it inside this, and the surface runoff on the other side. Any confusion? So the next, having kept the leachate to a minimum, leachate is still going to come out. So what? So how do we control this leachate? We have to take the leachate to the sides. The leachate should not pond up into the center of the landfill. So first we have a liner which prevents this leachate from going down into the soil. Drainage of leachate collected at the base of a landfill to the sides of the landfill, and then removal of the leachate from the sides. That's critical. So you have to have a convex shape at the base of your landfill or at the base of your phase, and I'll show that. The second is, our leachate collection layer is 30 centimeters thick, typically. That's the minimum specification. We've done that. So our leachate head should not be more than 30 centimeters thick. That means when I design the pipes inside the leachate collection layer, my design head is 30 centimeters or 1 foot. And then I have to collect and treat the leachate. So let's just see this. I have an above ground landfill. If I don't do the proper grading at the base, suppose the above ground landfill has a base like this going down and coming up. All the leachate will come to the center and you'll have to pump it out. It can't come up by its own because this is low lying. But if I fill it up and make it convex, then the leachate can come out from here and the leachate can come out from here. And the good thing is you don't need electricity, you don't need a pump. So in above ground landfills with a properly designed base, you can allow the leachate to come out through gravity. So it's visible to you, it comes out through a rock toe and you can collect it outside. And what are these slopes? These slopes are 2%. The ground slopes are 2%. If you are below ground, there's little that you can do. The leachate has to come out through pumping. So you can shape the base of your landfill such that leachate comes here and leachate comes here. And then you can remove it. You can either have a vertical well or something called a sloping well, a side slope riser. A riser pipe is like a well pipe. So you can have two options, a vertical well or a side slope riser. If you have a landfill on a slope, again lucky for us, if I do this properly and the leachate doesn't flow backwards to this corner, now you have to keep the slope outwards, then the leachate can come out by gravity again. So it's the below ground landfill in which the leachate has to be pumped out. And let's go back to the liner system that we talked about. So this is a single composite liner, the barrier layer, the compacted clay, the geomembrane, and on top of that, that means any leachate which comes to the side slope comes down, and any leachate which comes here comes down, and this is where it is collected. You will make a sump here for collection of your leachate. And I can see some pipes. When high flows are expected, then you have a 2% slope. You have to be able to handle the high flows. So perforated pipes are put within the 30 centimeter sand gravel layer. So leachate travels at 2% slope, and in that 2% slope are perforated pipes which are typically 15 centimeters in diameter, and leachate travels through this pipe to one corner where there is a pump to pump out the leachate. So let us say I have a 500 meter wide base, and if I give a 2% slope, what will be the difference in elevations of the two sides? 500 meter wide base, and I say I'll give a 2% slope, so 10 meters. That's a huge elevation difference. The percentage is only 2, but that's a huge elevation difference. So then you see what will happen is when the width is very large, if this is 500 meters, then a 2% slope will give you a 10 meter drop. So in such cases, the base of a landfill starts to look like this. With the drainage pipes. So you make the leachate flow in short lengths. You have to keep the earthwork to a minimum. You don't want a very elevated difference in the facilities. And then in this perpendicular direction, you take out your leachate. Okay? This is sometimes called the accordion arrangement. But it goes like a corrugated base. So the leachate drainage layer is usually 30 centimeters thick, has a slope of 2% or higher, and a permeability of greater than 10 to the power of minus 4 meters per second, or greater than 2 to the 10 to the power of minus 2 centimeters per second. A system of perforated pipes and sumps are provided within the drainage layer. So it becomes like a hydraulic design, flow in a pipe. So leachate is removed from the landfill by pumping in vertical wells or chimneys, pumping through side slope risers, or gravity drains to the base of a landfill in above ground and slope landfills. Side slope risers are preferred to vertical wells to avoid any down drag or tilt problems. If you have a vertical well and the waste is biodegradable, it settles. This might cause the vertical well to tilt. If you have a side slope riser, it is resting on the ground on the side slope. So side slope risers are typically preferred to vertical wells to avoid any down drag or tilt problems. So I've just shown you this leachate collection layer where this is a vertically exaggerated diagram. Okay? And again, please understand that this is the leachate collection pipe, and it should be surrounded by gravel, and the size of the gravel should be larger than the size of the perforations. Otherwise, the soil will go into the pipe, right? And around this is your sand gravel mixture, that is the leachate collection layer. And there has to be a geotextile or a filter between the gravel and the sand, so that the sand doesn't come and fill up the voids. So this is a typical leachate collection trench at the base of a landfill. So if I look at the top, you'll have main leachate collection pipes, and then you'll have cross pipes if required, and all of them will go and connect to a one sump in one phase. This is one phase, and you will take out the leachate through this phase. The design of these pipes are 15 centimeters, this layer is 30 centimeters thick. So you have a hydraulic design that you know the rate at which your peak leachate is being generated, so many cubic meters per hour. You don't want the head to be accumulated. So with this head, these pipes must be equal to match the Q which is coming down. If more Q is coming down, put more pipes. That means you have to reduce the spacing of the pipes. If less Q is coming, you can spread them out. Typically, these pipes may be 50 to 75 meters spacing, 100 meters spacing. Okay? And these are the two diagrams. This is a vertical well. So this is your sand drain. The well will have gravel at the bottom, and this is an HDPE pipe. Typically, you tend to avoid RCC pipes because the leachate can attack the concrete. Okay? And this is a side slope riser. So this is also an HDPE pipe. This is your leachate collection pipe. This will fill up with the leachate. There is a submersible pump here. There will be a submersible pump and a pipe here, and this will send up the leachate through the HDPE pipe and through this HDPE pipe. Here, as I said, there can be tilting problems as the down drag occurs, whereas here this HDPE pipe is sitting on this. And better have a double liner at the base of the sump, double composite liner, because this is always going to be full. This is going to be your weakest link. The sump is always going to be full of leachate. So all this area is not going to have the leachate. It's all going to come here. Similarly, all this is not going to have leachate. It's going to come here. So your sump should have a double composite liner. This is a combined leachate collection and gas collection well. We will probably look at this at a later date, but the idea is from the same well you can have a submersible pump and take out your leachate, and you can have an outer annular space from which you can collect the gas. And when we do gas collection system, I'll try to visit this again. Finally, you've got the leachate, it's come out from the pipe and from the pump. What are you going to do with it? That's the most expensive issue. In some areas, the evaporation is more than the precipitation. So a choice appears to be solar ponds. Solar ponds means you collect the leachate in a big pond, allow it to evaporate, it will become powder in the end. Only problem is lot of odor because leachate is exposed, right? Or you can use in-vessel containerized evaporation systems which are called multiple effect evaporators. So multi-effect evaporators, in fact there should be a gap here between effect and evaporator. These are forced evaporation systems. You take your leachate in the form of a slurry, you inject it, and that slurry at high temperatures, the liquid will evaporate, the salts will come out. So basically the technology is evaporate the leachate. And if you have an in-vessel MEE or a multi-effect evaporator, you have to have all the gas control, emission control measurements. You don't want the wrong gases going out by volatilizing. So evaporation of leachate, residue, the solids will go back to the landfill. Odor problems in solar ponds, management in monsoons is also a problem, but no problems in MEE. So multi-effect evaporators are expensive, but they work, and they are working at a couple of sites. Otherwise, your only option is to have an on-site ETP and an off-site ETP. An on-site ETP will be expensive, so if you have a large landfill, no problem, you can absorb the cost of an on-site effluent treatment plant. But if you are a small landfill, then there must be a sewage treatment plant in your vicinity. You will have to pre-treat your leachate and send it to the effluent treatment plant off-site. Then it can be sent in trucks, in tankers, huge tankers, to the off-site plant. So you have to see what works. Recirculation is also a strategy. That means you collect the leachate and pump it back into the landfill. So this works well with the concept of bioreactor landfills. You can stabilize the waste faster, but the leachate keeps on becoming more and more intense. Its quality keeps on becoming worse. Some contaminants do get held by the recirculation. Earlier they are there, later they are not there, but by and large the total leachate becomes more and more higher concentration. And even when you want to recirculate the leachate, please remember, it's not taking a pipe and putting it at the top of the landfill. How will you recirculate a leachate? You want the leachate to be equally spread out on your landfill, right? How will you, if you sprinkle it, then you are creating the same odor problems. You will have evaporation, but you are creating the same odor problems. If you want to inject it, if you have 5 points of injection, the leachate will go vertically down. So how do you recirculate leachate? If I have a phase, if I inject leachate at 6 locations, just put in a pipe and say, this will form a preferential seepage path. It's not going to spread all around, uniformly, right? When you are going to irrigate your lawn, you spray the material. So then you need a drip irrigation or a distribution system. So the better thing is to have a network, underground, below the cover, distribution network. So you can have injection at multiple points. So what it says at the end, you need a distribution pipe network under the cover for distributing the, this has to be different from the leachate, from the gas collection layer, which is also under the cover, so that you can uniformly make the waste wet and make this leachate. Otherwise it will go down in a preferential path. So these are the strategies for leachate treatment. I have seen solar ponds, multi-effect evaporators. I've seen off-site leachate being sent to off-site ETPs. We have not yet seen an on-site. Many people say the MEE is like an on-site ETP, which is correct, but people are talking of reverse osmosis as also an effluent treatment, and otherwise you have to have 3 levels of treatment: physical treatment, chemical treatment and biological treatment, especially for the MSW leachate. So with this we'll stop here. Just given you an overview about how to estimate the amount of leachate. Very simple, precipitation multiplied by the active area. That's a good thumb rule, plus 5% of the precipitation multiplied by the closed phases. So simple. And that's the amount of leachate that you are going to get to be treated. Peak precipitation rate, peak leachate rate, precipitation rate. So these are the two values that you need for hydraulic design. However, you can do many simulations and come up with the appropriate values. HELP is a good software to do this. Any questions or anything which is bothering you? Any clarifications you'd like to have? Eventually, the quantity of leachate goes down and the concentration of the leachate also goes down. Okay, thank you.